Imagine standing at the edge of the ocean. The waves crash at your feet. You look out and you think, okay, deep water, maybe a few miles down. That's it. That's the ocean. You're wrong, and not slightly wrong. You're catastrophically, mind-bendingly wrong. Because what you're picturing right now, that shimmering blue surface, those waves, even the deepest thing you've ever seen in a nature documentary, is barely the beginning. It's like looking at the lobby of a skyscraper and thinking you've seen the whole building, except the building goes 36,000 feet underground, except we've only sent humans down there twice, except at the very bottom, the pressure is so extreme it would crush a submarine like a paper cup. Today, we're going all the way down, and I promise you, by the end of this video, you will never look at the ocean the same way again. Part 2. The surface illusion. Let's start with a number that changes everything. The ocean covers 71% of Earth's surface. Most people know that, but here's what they don't tell you. The ocean also holds 97% of all the water on this planet, and its average depth, 3,688 meters. That's over 12,000 feet. That's 2.5 miles, just on average. But averages are deceptive, because the ocean isn't just a uniform deep bathtub. It's a series of completely different worlds, stacked on top of each other, each one more extreme and more alien than the last. Think about it like this. You know how a city has different levels: street level, the subway underground, the basements below that, the utility tunnels even further down. The ocean works the same way, except each level is darker, colder, and more hostile than anything you've ever imagined. And some of those levels are so far down, humans have explored them less than the surface of the moon. Here's something that should make your brain short-circuit. We have higher resolution maps of Mars than we do of our own ocean floor. Let that sink in. A planet 140 million miles away is better mapped than the world beneath your feet. So let's actually go there. Let's descend, zone by zone, and understand just how deep this rabbit hole actually goes. Part 3. The zones breakdown. Where you think the ocean ends. The first 200 meters. This is what basically all of humanity interacts with when they think of the ocean. Sunlight filters through here. You've got coral reefs, sea turtles, sharks, dolphins, schools of fish. It's beautiful. It's colorful. It's alive. This is called the sunlight zone, or the epipelagic zone, if you want the science name. And here's the wild thing. Almost all marine life that humans have ever seen, filmed, or studied lives right here. The entire surface ecosystem, all the iconic ocean imagery you've ever watched in a nature documentary, it all happens in this thin, paper-thin slice of the ocean, 200 meters, out of a maximum depth of over 11,000. That's less than 2% of the total depth, less than 2%. So you're telling me 98% of the ocean's depth is something else entirely? Yes, and it gets weird very fast. At around 200 meters, the sunlight disappears. Not dims, disappears. You hit a layer called the thermocline, where the water temperature drops sharply and rapidly. The color shifts from blue to deep indigo to absolute black. And you've just entered a world that most humans never even think about. Part 4. The Twilight Zone, where things get strange. Welcome to the Twilight Zone, or the Mesopelagic Zone, from 200 to 1,000 meters down. Here, the last faint traces of sunlight die out. You can still detect the faintest blue-green glow near the top, but by the time you hit 1,000 meters, it's zero light, none, total darkness. The pressure down here is already crushing. At 200 meters, the pressure is 20 times greater than at the surface. At 1,000 meters, you're looking at 100 atmospheres of pressure pressing on every single square inch of your body. For context, a car tire is typically inflated to about 2 to 3 atmospheres. At 1,000 meters, the ocean is pressing down on you with the force of 100 tires stacked on every square inch of your skin. And yet, life thrives here. Bizarre, alien life. You've got the lanternfish, which is actually one of the most numerous vertebrates on the entire planet. We just never see them because they live down here in the dark. You've got creatures with massive tubular eyes designed to catch the absolute last photon of light. You've got the hatchet fish, which looks like someone described a fish to a nightmare, and this is what came out. But here's something almost nobody knows. Every single night, millions of tons of marine life perform the largest migration on Earth. They rise from the twilight zone up to the surface to feed, then descend back down before dawn every night, like clockwork. Scientists call it the diel vertical migration, and it's happening right now, as you watch this video, across every single ocean on Earth. But we're not even close to the bottom. We've barely started. Part 5, the midnight zone. Total darkness, total silence. Below 1,000 meters, you enter the midnight zone, the bathypelagic zone. And this is where the ocean stops being recognizable as the ocean you know and starts feeling like another planet entirely. No sunlight. Zero. Not even a photon from the surface reaches here. The only light that exists down here is bioluminescence. Creatures generating their own cold, ghostly glow. Scientists estimate that up to 76% of all deep-sea creatures are bioluminescent. They flash, they pulse, they glow in patterns. Some use it to attract prey. Some use it to confuse predators. Some use it to communicate. And until recently, we had no idea any of this was happening. The temperature down here hovers just above freezing, around 2 to 4 degrees Celsius. The pressure at 4,000 meters is nearly 400 atmospheres. Food is incredibly scarce because there's no photosynthesis, so the entire food chain depends on what scientists beautifully call marine snow, tiny particles of dead organic matter that drift down from above like a slow, perpetual snowfall. Creatures down here have evolved to survive on almost nothing. Some anglerfish can go months between meals. Their metabolisms have slowed to almost nothing. And speaking of the anglerfish, can we talk about them for a second? Because the deep-sea anglerfish is one of the most horrifying and fascinating creatures that evolution has ever produced. It has a bioluminescent lure dangling from its head, essentially a glowing fishing rod, to attract prey in the absolute darkness. Its mouth is so large, relative to its body, that it can swallow prey twice its own size. Some species have teeth so long they physically cannot close their mouth. It looks like someone designed it specifically to haunt your dream. But even this alien world of darkness and crushing pressure and nightmare creatures, this is still not the deepest part of the ocean. Part 6, the abyssal zone, a desert in the dark. From 4,000 to 6,000 meters, the abyssal zone. And despite the terrifying name, this is actually where most of the ocean floor is. About 75% of the deep ocean floor sits in this zone. It's vast, it's cold, it's almost completely flat and featureless in most places. Just endless dark sediment stretching for thousands of kilometers. This is not the dramatic underwater landscape you might picture. In most of the abyss, there is nothing. No mountains, no coral reefs, no dramatic cliffs. Just a gray-brown seafloor covered in soft sediment. The accumulated remains of billions of years of marine snow slowly piling up. In some places, that sediment is hundreds of meters thick. It's a record of Earth's history, a geological time capsule, and we've barely sampled it. But even here, even in this vast dark desert, life finds a way. Sea cucumbers, which look less like animals and more like deflated socks, crawl across the seafloor, consuming sediment. Giant isopods, which look like enormous roly-poly bugs, the size of footballs, scavenge whatever falls from above. And then there are the hydrothermal vents. Hydrothermal vents are cracks in the seafloor where superheated water, sometimes over 400 degrees Celsius, blasts up from the Earth's mantle. And around these vents, in complete darkness, with no sunlight, with extreme heat and pressure, you find entire ecosystems. Tube worms that can grow up to 2 meters long, giant white crabs, shrimp that have evolved light receptors on their backs instead of in their eyes, life forms that don't use photosynthesis at all. They use chemosynthesis, deriving energy from chemical reactions rather than the sun. The discovery of hydrothermal vent ecosystems in 1977 was one of the most significant scientific discoveries of the 20th century. It completely rewrote our understanding of where life can exist and opened the possibility that life might exist in places we never considered, like the subsurface oceans of Jupiter's moon Europa. Part 7, the Hadal Zone, the deepest place on Earth. And now, we reach the bottom, the absolute bottom, below 6,000 meters, the Hadal Zone, named after Hades, the Greek god of the underworld, and for good reason. The Hadal Zone exists almost exclusively in ocean trenches, narrow, V-shaped scars in the seafloor where tectonic plates collide and one slides beneath the other. These trenches are rare, extreme, and then almost completely unexplored. The deepest of them all is the Challenger Deep, located in the Mariana Trench in the western Pacific Ocean. Its depth, 10,935 meters. That's 35,876 feet, almost 11 kilometers straight down. Let's make that number real. If you took Mount Everest, the tallest mountain on Earth at 8,849 meters, and dropped it into the Challenger Deep, the summit would still be over 2 kilometers underwater. Think about that. The highest point on land, completely submerged, with 2 kilometers of water above it. The pressure at the Challenger Deep is approximately 1,086 bars, over 1,000 times the pressure at sea level. If you were somehow transported there without protection, you wouldn't just die. The pressure would compress your body to a fraction of its size instantaneously. Your lungs would collapse. Every air pocket in your body would be destroyed in milliseconds. It is one of the most hostile environments on Earth, and yet, life exists there. Scientists have found amphipods, small crustaceans, crawling along the floor of the Challenger Deep. They've found single-celled organisms called foraminifera. They've found bacteria. They've even found microplastics, which is perhaps the most depressing scientific discovery of the modern era. We've never sent a single human being to explore most of this trench, and we've already managed to pollute it. As of today, only a handful of human descents have ever reached the Challenger Deep. The first was in 1960, when Jacques Picard and Don Walsh descended in a vessel called the Trieste. They spent just 20 minutes at the bottom. The second notable descent was in 2012, when filmmaker James Cameron, yes, the director of Titanic, made a solo dive in a specially designed submersible. More recently, Victor Vescovo descended in 2019, achieving the deepest crewed descent ever recorded. To put that in perspective, 12 people have walked on the moon. Fewer than that have reached the deepest point of our own ocean. Part 8. What Lives in the Deep. A. Monster Catalog. Let's talk about the creatures, because the deep ocean isn't just a geological curiosity, it's a biological one. And the things that live down there are so strange, so extreme, so beautifully weird, that they almost don't seem real. The giant squid. For centuries, sailors told stories of enormous sea monsters dragging ships beneath the waves. Scientists dismissed it as folklore, until we started finding evidence. Giant squid can grow up to 13 meters long. Their eyes are the largest of any living animal, up to 30 centimeters in diameter, about the size of a dinner plate, designed to detect the faint bioluminescence of predators in the deep ocean dark. For most of human history, we had never seen a live giant squid. The first photograph of a living giant squid in its natural habitat wasn't taken until 2004. The colossal squid, even larger than the giant squid, potentially reaching 14 meters, even less studied. We've caught fragments. We've found beaks inside sperm whale stomachs, but we've never seen one alive in the wild. It is the largest known invertebrate on Earth, and we have essentially no idea how it lives, what it does, or how many there are. The frilled shark, a living fossil. Its body plan has barely changed in 80 million years. It looks like someone crossed an eel with a shark and then stretched it. It has 300 teeth, arranged in 25 rows. It hunts by bending its body like a spring and lunging forward, snake-like. We almost never see them. They live at depths between 400 and 1,500 meters, and they're rarely caught. Most of what we know about them comes from dead specimens hauled up in fishing nets. The barrel-leaf fish, one of the most surreal creatures in the ocean. It has a completely transparent head, a dome of clear gelatinous tissue, and inside that dome are two cylindrical, barrel-shaped eyes pointing straight up. They're looking for the silhouettes of prey above them against the faint light from the surface, and they can rotate those eyes forward when they need to focus. It looks like a creature designed by a science fiction author who had never actually seen a fish. Scientists estimate that the deep ocean may contain up to 10 million species, most of which have never been cataloged. Every time a deep-sea expedition returns, researchers bring back new species, not new variations, new species, creatures that have never had a scientific name, creatures that have been evolving in the dark for millions of years, completely unknown to the surface world. Part 9. We know more about Mars, the exploration crisis. Here's the number that has always haunted me. We've explored less than 25% of the ocean floor. Some estimates put it as low as 5 to 10% for the deep ocean specifically. And we're talking high-resolution mapping here, actually understanding what's down there. For context, we have better maps of the surface of Venus than we do of Earth's own seafloor. Why? Because space exploration, paradoxically, is easier than ocean exploration. In space, once you're out of the atmosphere, there's nothing pushing back on you. You're in a vacuum. You can build thin-walled spacecraft. The Hubble Space Telescope has walls that are millimeters thick in places. But in the ocean, you're fighting against pressure that increases by 1 atmosphere for every 10 meters you descend. At full ocean depth, you need vessels capable of withstanding over 1,000 atmospheres. The engineering required is extraordinary and extraordinarily expensive. The Hubble Space Telescope cost about $10 billion over its lifetime. The Alvin, one of the most famous deep-sea research submarines, operated by Woods Hole Oceanographic Institution, operates on a yearly budget that is a fraction of that. We simply haven't invested in exploring our own planet with the same ambition we've used to explore the solar system. And this isn't just a scientific curiosity issue. The ocean is deeply, directly relevant to our survival. It regulates our climate. It absorbs roughly 30% of all the CO2 we pump into the atmosphere, and over 90% of the excess heat generated by global warming. The deep ocean circulation patterns, the thermohaline circulation, sometimes called the ocean conveyor belt, regulate temperature across entire continents. If those patterns shift, Europe gets dramatically colder. The American East Coast weather patterns destabilize. Agriculture around the world is affected. We are dependent on a system we don't understand, driven by processes happening in places we've never been. That's not just scientifically embarrassing, it's dangerous. There are mineral nodules on the abyssal plains, potato-sized rocks rich in manganese, cobalt, nickel, and rare earth elements that our technology desperately needs. There are biological compounds in deep-sea organisms that could have pharmaceutical applications we haven't begun to explore. There are geological processes happening in the deep ocean that affect seismic activity and volcanic eruptions on land. We are flying blind over a system that controls the conditions for human civilization on Earth. So let's come back up, all the way back to the surface, back to those waves crashing at your feet. You now know that beneath that surface is a world that goes down 11 kilometers, that it passes through zones of fading light, then total darkness, then crushing pressure, then alien life forms that have never seen the sun. You know that the creatures living there are stranger than anything science fiction ever invented. You know that we have better maps of other planets than of our own ocean floor. You know that the deep ocean isn't some inert geological feature. It's an active, living system that governs the climate of the entire planet. And the next time you stand at the ocean's edge, I want you to feel that. Not just the waves, not just the horizon, but the weight of everything beneath. The 11 kilometers of darkness and pressure, and life and mystery that stretches down to a world we've barely touched. That's the real ocean, and it's far, far deeper than you ever thought.